The silence before everything was not the kind of silence we know. It was not the stillness of an empty room, nor the hush between heartbeats. It was a silence beyond absence, a pause that existed before sound had a name, before existence had a reason to hum. There were no atoms, no stars, no time to measure the waiting. There was not even darkness, for darkness is something. This was the silence of a universe that did not yet exist, a pause in which possibility rested like a breath not yet drawn. Scientists call it a singularity, a state so dense and hot that the laws of nature lose their shape. Philosophers call it nothingness, though nothingness itself may be too human a word. Some imagine it as a perfect void, others as a boundless field of potential, an ocean of energy without waves, a sleeping thought that has not yet dreamed. What could it mean for there to be no space, no distance between things, because there were no things at all? Even to imagine it is to create form where there was none, to paint color onto the invisible. Yet we try. We are creatures who need beginnings, and so we whisper about what came before beginnings were possible. In ancient mythologies, this pre-existence is described in many voices. The Greeks spoke of chaos, not disorder, but the yawning gap, the great emptiness from which everything would someday arise. In Hindu cosmology, there is Brahman, the eternal, unmanifested consciousness, neither being nor non-being. The Norse called it Ginnungagap, a void between fire and ice, a fertile emptiness waiting to ignite. Across cultures and centuries, humanity has looked into the silent space before creation and seen both terror and peace. Something within us recognizes that silence, perhaps because we are born from it. Modern cosmology, too, begins with a kind of reverence for the unseeable. Our universe, as far as physics can tell, expanded from a point smaller than imagination, in a burst we call the Big Bang. But even that phrase, the Big Bang, is misleading. There was no bang, no explosion into space, for space itself did not exist yet. The universe did not burst into the void. It was the void reshaping itself. The laws of physics, the constants of nature, the very idea of laws, all were born in that first infinitesimal moment of awakening. Before that, the equations we use to understand reality break down completely. Time, as we know it, had not yet opened its eyes. And yet, in that pre-time silence, something stirred. Perhaps it was a fluctuation, a ripple in the quantum vacuum, the brief spark of instability that tipped the balance from nothing to everything. Or perhaps it was inevitable, a truth embedded in the fabric of possibility itself. In the deepest mathematical sense, nothing is unstable. Even in total emptiness, uncertainty seethes. Tiny fluctuations blink into being and fade away, their ghostly presences like brief thoughts in the mind of eternity. One of these fluctuations, for reasons we may never understand, did not fade. It expanded. It became the story we now live inside. What did that silence feel like? The question is almost paradoxical. Feeling requires form, a nervous system, a pulse, a mind. But the beauty of the question lies not in its answer, but in its invitation. To wonder what the universe was before it had form is to press our consciousness against the limits of knowing. It is to stand at the edge of understanding and listen to the faint hum behind reality, the background note from which all melodies arise. Imagine, for a moment, that you could stand outside of time, that you could listen to the pause before the first sound, before light found direction. You would not see blackness, for black requires contrast. You would not feel stillness, for stillness implies the possibility of motion. What you might sense, instead, is a perfect equilibrium, a balance so profound that it contained every future disturbance. Within that balance, every atom that would ever exist was encoded, every law that would govern matter already written in the silent fabric of being. Perhaps the silence before everything is still here. Perhaps it was never gone. The background quiet that hums beneath every sound, the space between thoughts, between breaths, between stars, may be the same silence that existed before form. The Big Bang may not have destroyed it, only shaped it into something we can experience. The silence before everything may not be a thing of the past but the foundation of the present, the stillness that allows the universe to move, just as silence allows music to be heard. And if you listen closely, not with ears but with awareness, you can almost sense it, the quiet patience of existence itself. The waiting that never ended. The breath that was not yet air. The first whisper of what it means to be.
Before the first star, before light had a direction, before anything could be called real, there was only a trembling field of potential. It was not space, not emptiness, not energy in the way we understand it now. It was the raw uncertainty from which energy itself could someday arise, an endless ocean without surface, without depth, vibrating with the possibility of becoming. In that ocean, every point was identical, every law of nature perfectly balanced, every direction meaningless. There was no up or down, no here or there, only the potential to one day become difference. This was the breath that wasn't yet air, the silent inhale before creation, the tension before release. In physics, some call this state the quantum vacuum, though vacuum is a misleading word. It was not empty, not void, but alive with fluctuations, momentary blinks of existence that appeared and vanished faster than time itself could be measured. Particles and antiparticles rose from the nothing, collided, and cancelled, leaving behind no evidence but the memory of motion. Each fleeting pulse was a question the universe asked itself. Should I continue? Should I stay? For an eternity that existed outside of time, the answer was always no. Until, somehow, it became yes. The idea that something can arise from nothing seems impossible, and yet the mathematics of quantum theory suggests that nothingness is never truly empty. Even in what we call void, there exists a restless energy, an eternal vibration at the smallest scales of reality. This fluctuation is the quantum breath, the universe exhaling possibility into itself. In that trembling field, symmetry reigned supreme. Every force, every law, every constant that would later shape galaxies was unified, resting in perfect stillness. It was a balance so complete that it could not last, for absolute symmetry is inherently unstable. Perfection, by its nature, must shatter to create anything new. Physicists describe this as spontaneous symmetry breaking, the moment when the universe's perfect order gave way to imperfection. Imagine a pencil balanced upright on its tip, mathematically stable, but in practice, doomed to fall. The universe was that pencil, balanced on the knife edge of eternity. When it tipped, it did not fall into chaos, but into structure. Forces that had once been one, gravity, electromagnetism, the strong and weak nuclear interactions, began to differentiate, each taking on its own identity. In that subtle act of imbalance, reality unfolded. The breath was drawn in. The universe had begun to inhale. And yet, the breath was not a sound, not a wind. It was a whisper written in mathematics, in the language of probabilities and fields. At the Planck scale, the smallest possible scale of distance and time, space itself foamed and flickered. The quantum foam, as it is called, is the seething foundation of reality. It is not static, but dynamic, an ocean where tiny wormholes and microscopic bubbles of space-time appear and vanish in immeasurable moments. To look at this level of existence is to see not form but rhythm, an endless trembling that never resolves, like the vibration of a note that has not yet found an instrument. Perhaps this trembling is the universe's first expression of emotion, if such a poetic term can be allowed. A yearning, perhaps, to move from stillness into story. Every fluctuation, every imbalance, every uncertainty was a kind of anticipation, as though the void itself longed to know what it could become. In the spiritual language of humanity, this longing has been called many names: the divine will, the creative impulse, the unfolding of the one. In the scientific language of cosmology, it is known as inflation, the rapid exponential expansion that followed the tiniest moment of instability. During that unimaginably brief instant, the universe expanded faster than light, stretching from subatomic to cosmic scales in less than a heartbeat. Space itself swelled, driven by the vacuum's own energy, and the fluctuations that once existed only as whispers became the seeds of galaxies, stars, and life. Those random quantum ripples were frozen into the fabric of spacetime, etched permanently as patterns of density and emptiness. The cosmic microwave background, the faint glow we still detect today, is the fossilized echo of that first breath. The universe inhaled once, and that inhale never truly ended. It is still expanding, still breathing, billions of years later. It is strange and beautiful to think that everything, every atom in your body, every beam of starlight that reaches your eyes, began as a fluctuation in that primal field. The carbon in your cells, the iron in your blood, the thoughts you form in the quiet of your mind, all trace their lineage back to the trembling before time. You are, in a very literal sense, the residue of the universe's first uncertainty, the exhalation of its first invisible breath. The breath that wasn't yet air carries a lesson that is both scientific and deeply human. Creation does not begin with fullness, but with potential. The beginning of everything was not a bang, not a flash of chaos, but a soft quiver in the stillness, an unsteady motion that grew until it filled the infinite. In that sense, the story of the universe is the story of every moment we hesitate before beginning, every quiet second before a word is spoken, every tremor before an idea becomes real. The silence that came before creation was not absence, it was readiness. The trembling field was not confusion, it was anticipation. And when that anticipation finally tipped into existence, the universe took its first breath, a breath that never ends, a breath we are still a part of. We inhale and exhale with it, unaware that every breath we take continues the rhythm that began before air itself existed. Perhaps this is what the universe looked like before it had form, a breath without lungs, a movement without motion, a thought before mind. The quantum field did not know what it was becoming, it only knew that it could. And from that single formless possibility, everything, time, space, matter, life, consciousness, would unfold like music from silence. Perfection, for all its beauty, is lifeless. It is still complete and unchanging, and therefore incapable of creating. In the earliest whisper of existence, before galaxies, before even atoms, the universe existed in a state of perfect symmetry. Every law, every force, every potential mirrored its opposite with flawless precision. Matter and antimatter were born together, equal and opposite, their dance perfectly balanced. But from that balance, nothing enduring could emerge. It was a mirror looking into itself, infinite reflection, infinite sameness. For anything to happen, that mirror had to crack. And when it did, imperfection was born. The first flicker of imperfection was not a mistake. It was the beginning of everything. Physicists call it baryon asymmetry, the slight imbalance between matter and antimatter that allowed our universe to exist. For every billion particles of matter that appeared, nearly a billion antiparticles appeared too, and when they met, they annihilated each other in bursts of pure light. But 1 in a billion remained, one small deviation from perfect symmetry, and that deviation became everything we know, every atom, every planet, every mind. Without that flicker, the universe would have remained a radiant nothing, a sea of light without structure or story. It is humbling to think that existence depends on a flaw so subtle, so improbable, that it could have easily never happened. The laws of physics are finely tuned, balanced on the edge of inevitability and chance. Some theories suggest that even a tiny change in the early conditions, a different value for a constant, a slightly altered quantum fluctuation, would have yielded a universe with no matter at all, no galaxies, no us. That one flicker, that one breath of imbalance, was not a failure of perfection, but its transformation into meaning. In that ancient instant, the universe became asymmetric, a word that sounds scientific, but is deeply poetic. Symmetry is serenity, but asymmetry is life. The asymmetry that broke the early universe's balance is echoed in everything we know. It is in the spiral of galaxies that are not perfectly round, in the tilt of our planet that brings the rhythm of seasons, in the slight imperfection of DNA that allows evolution. Even the human face, with its small asymmetries, carries character, emotion, and beauty precisely because it is not flawless. In every sense, existence itself is the art of imperfection. At the quantum level, the imbalance between matter and antimatter may have arisen through a phenomenon known as CP violation, the tiny preference the universe shows for matter over antimatter. It is one of the deepest mysteries in physics. Why should the cosmos favor one over the other? Why should existence lean ever so slightly towards substance instead of void? Perhaps there is no reason, or perhaps the reason lies beyond what science can yet see. It may be that the laws of nature contain within them a quiet bias toward creation, a cosmic preference for being over non-being. But even as physics searches for equations, there is something profoundly human about this story. It mirrors our own experience, the idea that growth comes not from perfection, but from imbalance. A perfectly contented life might be serene, but it would also be static. It is restlessness that drives motion, uncertainty that drives discovery. Just as the early universe needed imperfection to evolve, we need questions, desires, and incompleteness to become who we are. The flicker of asymmetry that gave birth to stars and life is the same flicker that ignites curiosity in the human mind, the same inability to rest in stillness that propels us to seek meaning. After that first imbalance, energy condensed into matter, and matter began to interact. Hydrogen, the simplest element, emerged from the cooling chaos, followed by helium and trace whispers of lithium. These atoms, born from the imbalance of opposites, would one day form the bones of galaxies. The first imperfection rippled outward, creating structure, direction, and time. It was as though the universe had opened its eyes for the first time and seen its own reflection, not perfect, but alive. If we were to imagine that moment poetically, it might have felt like a pulse, a vibration in the still fabric of being, a soft stirring in the endless quiet. The balance between being and not being had tipped, and from that tipping point, momentum began. Existence, once potential, began to flow. The first flicker of imperfection was not chaos, it was creativity. The universe was learning how to move, how to breathe, how to make distinction. In that flicker, light and darkness found their roles. Expansion began, stretching the newborn universe outward, carrying with it the scars of that early imbalance. Every galaxy that would someday shine, every living creature that would someday think, every atom that would someday combine into thought, all of it can trace its origin to that first infinitesimal divergence. It is as if the cosmos whispered to itself, "Let difference be." And so the story of imperfection became the story of form. The particles that survived annihilation became the architects of stars and planets. The energy released by their collisions became the light that still travels through the sky. Even now, billions of years later, we live within the echoes of that flicker, the uneven afterglow of creation. The cosmic microwave background, faint and nearly uniform, carries tiny ripples, 1 part in 100,000, that reveal the original asymmetry of the universe. Those ripples are the fingerprints of that first flaw, the gentle proof that perfection broke. And through that breaking, we became possible. There is a strange peace in knowing that imperfection is not a curse, but the seed of all existence. The crack in the symmetry was not an accident. It was the beginning of beauty. Every sunset, every heartbeat, every fragile balance between order and entropy is a continuation of that moment. The universe did not choose perfection, because perfection cannot evolve. It chose difference, and through difference, it learned how to be. Perhaps, then, the first flicker of imperfection was not an error in the cosmic design, but the first act of self-expression, the universe's way of saying, "I will not remain still." In that flicker, potential became movement, silence became song, and the perfect stillness of nothing became the imperfect, miraculous story of everything. Before the first second could be counted, before moments could follow one another, there was no time. There was only existence, suspended, timeless, without direction or duration. To us, the idea of no time feels impossible because we live entirely within it. Every heartbeat, every thought, every breath we take unfolds through time's invisible river. But in the beginning, before that river began to flow, there was only stillness, not the stillness of rest, but the stillness of a universe that had not yet learned to move. Then, somewhere within that stillness, time opened its eyes. Time did not appear as a ticking clock or as the slow passage of days. It was not something the universe contained. It was something the universe became. When the Big Bang occurred, space and time were born together, woven into a single expanding fabric we call space-time. In that instant, distance and duration came into being as one. To move through space was to move through time. To exist was to change, and to change was to experience the unfolding of moments. What had been timeless potential now became story. Physicists often describe this as the emergence of the arrow of time, the direction in which events unfold. We can move freely through space, but not through time. We can look back into the past, but never return to it. We can imagine the future, but never touch it. This arrow gives our lives direction and meaning. Without it, cause and effect would dissolve. Nothing could follow from anything else. Yet, according to the laws of physics, most fundamental equations are time-symmetric. They do not prefer a direction. If you were to reverse time in those equations, the universe would still make sense. The question then arises, why does time flow forward for us? Why does it feel irreversible? The answer lies in entropy, the gradual drift of everything from order to disorder, from concentrated energy to diffusion. Entropy is what gives time its sense of direction. In the earliest moments after the Big Bang, the universe was in a state of astonishing simplicity and order. Energy compressed, matter undifferentiated, symmetry nearly perfect. As expansion began, that order slowly unraveled. Energy dispersed, matter scattered, and structure emerged from imbalance. Entropy increased and continues to increase. It is not chaos. It is evolution, the spreading of possibility across space and time. It is why stars burn out, why mountains crumble, why we age, and why memories are made. Entropy gives time its heartbeat. In those first seconds after creation, the universe expanded unimaginably fast, cooling as it grew. The first particles collided, combined, and scattered again in a furious dance. In that fiery instant, time was measured not in seconds, but in fractions of moments, so brief they defy comprehension. 1/trillionth of a second, and forces began to differentiate. A second, and particles formed. 3 minutes, and the first atomic nuclei came into being. Time had begun to move, and in its movement, history was born. But time is more than a measurement of change. It is a mystery of perception. Einstein showed that time does not flow at the same rate for everyone. It bends and stretches depending on speed and gravity. Near a black hole, where gravity warps space-time to its limits, time slows almost to stillness. For light itself, which travels at the ultimate cosmic speed, time does not pass at all. A photon leaving a distant star billions of years ago experiences no duration on its journey to our eyes. To it, emission and arrival are the same event. In that sense, light lives outside of time, eternal and unaging. Perhaps the universe, too, once existed in that timeless state before its expansion gave rise to duration. This invites a profound thought. Time may not be something that flows, but something that simply is. The past, present, and future might all coexist, like pages in a book. We turn the pages one by one, and to us, the story seems to move forward. But to the book itself, all pages exist simultaneously. The universe could be that book, and consciousness the act of reading it, experiencing each moment as if it were new, though all of them already exist in the grand tapestry of space-time. In that view, time did not begin, awareness did. Philosophers and mystics have often reached similar conclusions from very different paths. In ancient thought, time was seen as both cyclical and eternal, the endless wheel of creation and dissolution, birth and death, expansion and collapse. Hindu cosmology speaks of kalpas, vast cycles of time in which universes are born and destroyed like breaths of the cosmic being. The Stoics describe time as a fire, ever consuming and ever renewing. Even modern cosmology entertains the idea of cyclic universes, where each Big Bang is followed by a big crunch, and the silence between them is the cosmic inhale before the next creation. And yet, to us, fragile, living beings caught in the middle of time's current, it feels utterly linear. We age. We remember. We dream. We move toward something, though we can never quite say what. Perhaps our experience of time's flow is the price of being alive within the story, rather than outside it. A fish cannot see the river it swims in. A heartbeat cannot pause to listen to its own rhythm. So too are we immersed in the motion of moments, unable to stand apart and see time as it truly is. Still, if we slow our thoughts enough, if we listen between heartbeats and breaths, there is something beyond the ticking of clocks. There is a silence that feels older than time, the same silence that existed before time opened its eyes. It is there in meditation, in dreams, in the moments when everything feels perfectly still. For an instant, we return to that timeless state, the one that came before expansion, before change, before becoming. Perhaps that silence is not a memory of the beginning, but a constant presence, the eternal backdrop against which time unfolds. Time began as the universe began, and one day it may end. When the stars fade and motion ceases, entropy will reach its maximum, and time, as we know it, will lose its meaning once again. The river will dry, the story will close, and silence will return, not as an ending, but as a homecoming. And maybe then, as in the beginning, the universe will rest once more in that breathless pause, ready to open its eyes again. The universe had learned to breathe, and with that breath came the first light. Not the kind of light we see in the sky, not the warmth of a sun or the glow of a candle, but a primordial illumination that filled all of space with the echo of existence itself. In the earliest moments, the cosmos was a dense, hot plasma of particles and photons, an opaque sea through which nothing could travel far. Light existed, but it could not escape, trapped in a dance with matter, bouncing, scattering, weaving the first threads of the universe's story. This was the song of the first light, a hum of possibility that would eventually become the stars and galaxies we now see. As the universe expanded and cooled, a remarkable transformation occurred. Approximately 380,000 years after the initial breath of creation, atoms began to form. Electrons bound with protons to create neutral hydrogen, and suddenly the universe became transparent. Light could travel freely for the first time, no longer trapped in the plasma. This event, known as recombination, marked the release of the cosmic microwave background, a faint but persistent glow that still washes the universe today. In that moment, the song of the first light traveled outward, carrying with it the memory of the universe's earliest moments, the imprint of what had been and the promise of what would become. To imagine this is to enter a meditation on the origin of perception itself. Every photon of that first light traveled across the newborn cosmos, a silent messenger carrying the echo of creation. Each carried within it a story of motion, collision, and balance, a record of the universe learning to exist. It is as though the universe had composed its first symphony, a soundless music of radiation and particles, and sent it rippling outward through the void. That music, frozen in time, is what we can detect today, 8 billion years later. The universe sings still, and we, in some small way, can hear it. The first light was more than an event of physics. It was a revelation. It revealed structure where there had been only potential. Tiny fluctuations in density, seeded by the quantum foam before the expansion, were frozen into the fabric of space. These small variations became the blueprint for galaxies, clusters, and vast cosmic filaments. In the song of the first light, the universe composed the first notes of structure, arranging the seeds of all that was to come. Without this light, without this initial illumination, the cosmos would remain a shapeless, undifferentiated expanse, its beauty hidden in eternal obscurity. Philosophically, this light is a meditation on emergence, how complexity grows from simplicity, how consciousness grows from raw energy. At first, the universe was uniform, unbroken, a single note of existence. But within that note, within that first illumination, there were variations, tiny imperfections that allowed evolution to begin. Light became a storyteller, revealing patterns where none had been visible before, highlighting the contrasts that make perception possible. In a sense, the first light allowed the universe to see itself, to recognize form in the midst of formlessness. The song of the first light is also a reflection on memory. Every photon carries the imprint of the conditions in which it was born. When we detect cosmic microwave background radiation today, we are looking not at distant stars, but at the echo of a universe before stars even existed. We are seeing a photograph of a cosmos 380,000 years old, the ghostly memory of a time when matter and energy were inseparable, when the universe was learning to be. In that light, the cosmos remembers its own birth, and in observing it, we too become participants in that memory. There is an intimacy in considering the first light. We who are composed of the ashes of stars are inextricably connected to the photons that have traveled billions of years to reach us. The elements forged in stars and scattered across space form the atoms in our bodies. The light that illuminates our world carries within it the record of ancient events, the echoes of processes that began in the earliest flickers of existence. In seeing light, we are not merely witnessing, we are remembering. We are retracing the journey of the cosmos itself, feeling the pulse of its early song. This light also illuminates the contrast between emptiness and fullness. Before it, the universe was opaque, uniform, and undifferentiated. After it, space became textured, rich with information, and pregnant with possibility. The first light did not just shine. It whispered the secrets of the cosmos, hinting at the galaxies, stars, and planets yet to form. In that illumination, the universe began to articulate its own narrative, establishing a framework upon which every cosmic event would later unfold. Consider, too, the quiet persistence of this ancient glow. It is still traveling, still reaching into the void, still carrying the story of beginnings. Though we perceive it as microwave radiation, faint and diffuse, it remains one of the most profound reminders of continuity. The universe, once opaque and chaotic, now speaks through this song, a constant hum linking the origin to the present, the formless to the formed, the unimaginable past to our conscious now. In the song of the first light, we perceive both origin and potential. It is a reminder that even from extreme density, from confusion, from chaos, there can emerge clarity. That light, born of interaction between particles and energy, was not just illumination, but revelation. It taught the universe about itself, revealing what would exist, and providing the blueprint for what could come. It was a gentle introduction to existence, a patient whisper of the cosmos' unfolding story. Perhaps the most profound lesson of the first light is its subtlety. It did not roar into being. It did not declare itself with violence or grandeur. It was gentle, pervasive, a patient hum spreading through the newborn universe. It invited the cosmos to grow, to differentiate, to become aware. And in that awareness, everything that followed, galaxies, stars, planets, life, consciousness, found the conditions necessary to emerge. The universe learned to see, and through that seeing, it began the endless work of creation. And so, the first light sings still, faint, and eternal, a whisper of what once was and what will always be. It carries the memory of the universe's earliest breath, the echo of symmetry broken, the first pulse of structure emerging from formlessness. In listening to it, in contemplating its quiet song, we are connected to the very beginning, participating in the original rhythm of existence, and perhaps, for a moment, feeling the universe learn to know itself. The universe is not still. Even in its earliest moments, after the first light had traveled through the newborn cosmos, the fabric of existence itself began to move, to tremble, to vibrate. Space-time, once uniform and unyielding, developed subtle ripples, tiny undulations in its otherwise perfect expanse. These were the first gravitational waves, faint pulses that carried energy and information across the void. They were not sound in any sense we could hear, but in their movement was a rhythm, a resonance, the earliest music of the cosmos. The universe had begun to feel itself, to stretch and sigh, to remember that it existed. Gravity is often thought of as a static force, something that pulls matter together, shapes orbits, and keeps planets in place. But in its essence, it is dynamic, a force that responds to energy and motion, bending space and time along with it. When massive objects accelerate or collide, the distortion they create in space-time spreads outward like ripples on a pond. In the universe's infancy, when matter was clumped into uneven densities, these ripples traveled vast distances, carrying information about the distribution of mass and the processes that created it. They are echoes of the earliest moments, whispers frozen into the fabric of reality. These waves are not just scientific curiosities. They are a meditation on movement and memory. The universe, even in its formlessness, remembers. Every oscillation of space-time is a record of events, a trace of energy that once existed and will exist again. Gravitational waves remind us that movement leaves its mark, that existence itself is a record of processes unfolding over time. They are the pulse of the cosmos, faint and nearly imperceptible, yet universal in scope. Every galaxy, every star, every particle has been shaped in some way by these early tremors, and every moment we experience is built upon them. At a fundamental level, these vibrations connect the smallest scales to the largest. The quantum fluctuations that seeded the first structures in the universe became amplified as space expanded, and their energy propagated outward as gravitational waves. They are a bridge between the imperceptible and the immense, the microcosm and the macrocosm, showing us that even the tiniest fluctuation carries with it the potential for cosmic consequence. In their steady, imperceptible rhythm, we see the universe learning to speak in the language of energy, shaping itself through the movement it has carried since the first fraction of a second. Poetically, we might think of these waves as the heartbeat of the cosmos. They are not bound by the ticking of time as we experience it, nor by the limitations of space. They exist everywhere and nowhere, passing through matter without resistance, bending distances by imperceptible amounts. In every collision of black holes, in every merging of neutron stars, the universe produces echoes of its own dynamism. And in the earliest moments before stars or galaxies, these ripples were the first movement of matterless space, the trembling of existence itself learning its own possibilities. These waves remind us of contrast, of stillness and motion, of the known and the unknown. The universe, which had once been a formless, uniform expanse, began to develop texture and rhythm. Every fluctuation, every ripple, became a subtle sculptor, influencing the clumping of matter and the formation of structure. The trembling of space-time is the quiet prelude to all cosmic architecture. Even now, as gravitational waves wash through the cosmos at near light speed, they carry with them the memory of these earliest tremors, connecting the past with the present, the invisible with the tangible. If we think of consciousness as emerging from complexity, then the early vibrations of the universe might be seen as the first stirrings of awareness. Not sentient, not intentional, but a proto-awareness, a way for existence to register itself. Each ripple was a small acknowledgement of being, an imprint of the universe upon itself. In this way, movement precedes form, memory precedes structure, and rhythm precedes perception. The universe was practicing the art of knowing itself before it had stars to shine or life to witness. Gravitational waves also highlight the subtle beauty of scale. A fluctuation on a subatomic level can grow, amplified across time and space, into structures that shape the cosmos. Tiny imbalances in the early universe, invisible and ephemeral, guided the formation of galaxies, clusters, and filaments. In their passage, they create correlations, relationships, and patterns. Every cosmic structure is, in a sense, a note in the symphony of the universe's first tremor. The vast tapestry of space and time carries within it a memory of these earliest movements, a silent music that resonates to this day. The poetic truth of these ripples is that motion is the foundation of reality. Without the first trembles of spacetime, matter would never have clumped, stars would never have ignited, and galaxies would never have formed. The cosmos is not a static stage. It is an evolving dance, a performance of energy and gravitation, where every participant, from the tiniest particle to the largest cluster of galaxies, moves in resonance with the original vibrations. Each wave, each pulse, is a reminder that creation is not a single act, but a continuous unfolding. In contemplating these subtle movements, we are invited to reflect on our own place in the cosmic rhythm. The human heart, too, beats without notice, carrying the pulse of life through its quiet cadence. The trembling of consciousness mirrors the trembling of space, the subtle feedback of awareness echoing the universe's own primordial pulse. Every step we take, every thought we form, is a continuation of the rhythm that began before stars, before light, before form itself. Perhaps the greatest wonder of these early tremors is their persistence. Even after billions of years, gravitational waves produced by the universe's infancy still propagate, faint but unbroken, through the vast expanse. They are reminders that the universe retains memory, that energy carries history, and that every motion leaves an imprint. In their quiet, imperceptible passage, we can imagine the universe listening to itself, learning from itself, and shaping its own story through the subtle poetry of motion. The fabric of reality trembles even now, and in its trembling, we glimpse the echoes of a time before structure, before form, before life. These ripples are the voice of a universe learning to be, speaking in a language older than matter, older than light, older than time. In listening, even silently, we participate in that voice. We are, in some small way, vibrations within vibrations, resonating with the cosmic song that began with the fabric itself learning to tremble. After the first light had traveled freely and the early vibrations of the universe had begun, a period of darkness settled over the cosmos. It was not darkness as we perceive it now, for perception requires eyes and light to strike them. This was a darkness absolute and profound, a cosmic night that lasted millions of years. The universe was filled with hydrogen and helium gas, but stars had not yet ignited. Galaxies did not exist. Planets, moons, even the simplest compounds were still unborn. It was a quiet epoch, the so-called cosmic dark ages, a time of invisible potential, of hidden fire yet to awaken. In this vast emptiness, the universe seemed to dream itself into being, holding its first long, patient breath. During this dark age, matter was evenly distributed, and the cosmos was opaque in its simplicity. Small fluctuations in density, seeded by the first trembling of spacetime, began to grow imperceptibly under the influence of gravity. These fluctuations were tiny, almost undetectable, yet they contained the blueprint for everything to come. Clumps of hydrogen and helium slowly gathered, forming invisible filaments that stretched across the young universe. This was the scaffolding of structure, the invisible architecture upon which light and life would eventually dance. The universe, though seemingly empty, was teeming with potential, an ocean of matter waiting for the spark of ignition. The concept of darkness here is both literal and metaphorical. There was no illumination from stars, yet the universe was far from inactive. Every particle, every quantum fluctuation, every slight variation in density was part of a silent choreography. The Dark Ages remind us that creation often occurs in hidden spaces, in the quiet moments before eruption. Just as a seed lies dormant beneath soil before sprouting, the universe held the promise of brilliance beneath this shroud of opacity. There is a poetry in this invisibility, a meditation on patience and anticipation. Eventually, the densest regions of gas began to collapse under their own gravity. These pockets would become the first stars, igniting the long-awaited cosmic fires. But before that, the darkness persisted, offering a contrast that would make the emergence of light all the more remarkable. In a universe without illumination, every subsequent glow carries the weight of anticipation. The Dark Ages are, in a sense, a reminder that stillness, invisibility, and quiet are as essential to creation as energy and fire. They are the womb in which the universe nurtures its first expressions of structure and beauty. During this epoch, the universe was also learning to expand and cool. Its energy was spread across immense distances, and matter was too diffuse for nuclear fusion to occur. Temperatures dropped gradually, preparing conditions suitable for the first stars. Though there was no visible light, radiation pervaded the cosmos, a background hum of energy that would one day seed the formation of luminous structures. Even in this profound darkness, the universe was active, practicing the subtle art of emergence. This hidden fire, though not yet visible, carries a lesson about potential. Darkness is not absence, it is preparation. The universe's earliest epoch teaches us that moments of invisibility and stillness are not wasted. They are the canvas upon which brilliance will be painted. Without these long, patient periods, the universe could not have built the complexity necessary for galaxies, planets, or life itself. In contemplating this dark age, we are invited to appreciate the silent intervals in our own lives, the quiet, preparatory periods that precede growth and illumination. In the metaphorical sense, the cosmic dark ages mirror the unconscious mind. Like the unseen currents beneath the surface of thought, the universe was forming structures, shaping possibilities, and gathering energy, all without awareness of what was to come. It is a reminder that transformation often occurs beneath visibility, that profound change can take place long before it becomes apparent. The hidden fire is patient, persistent, and essential, guiding the universe toward the eventual awakening of stars and galaxies. Eventually, the first sources of light would break through this profound darkness. The ignition of the earliest stars, the formation of galaxies, and the release of radiation would transform the universe from a silent, invisible expanse into a cosmos rich with structure and illumination. Yet, even as light emerged, the memory of the Dark Ages remained, the subtle imprint of quiet and potential woven into the fabric of existence. It is a testament to the power of patience, the beauty of latent possibility, and the enduring presence of hidden energy that shapes all that follows. The Dark Ages are a meditation on the unseen forces that sculpt reality. They are the quiet prelude to brilliance, the invisible stage upon which all cosmic drama unfolds. Every star, every galaxy, every photon of light carries within it the memory of this hidden time. In contemplating it, we are reminded that creation often begins in silence, that the universe's first acts of patience are as important as its later displays of splendor. Darkness, in this sense, is not emptiness. It is the fertile void in which existence learns to dream. And so, in this age of darkness and hidden fire, the universe rested, waited, and prepared. It gathered energy, organized matter, and nurtured the seeds of structure that would one day shine as galaxies. There was no light to see, no form to touch, and yet the cosmos was awake in its own subtle way, practicing the quiet, patient rhythms that would give rise to all that followed. In this meditation, we are invited to feel the stillness, to hear the silence, and to understand that even in invisibility, creation is profoundly alive. The universe had spent millions of years in darkness, a quiet expanse of gas and nascent potential, and then, slowly, a transformation began. In the densest pockets of hydrogen and helium, gravity's patient hand gathered atoms together, compressing them into ever tighter spheres. Pressure rose, temperatures climbed, and finally, the first stars ignited. These were not the calm suns we see today, but titanic furnaces, massive and short-lived, burning with brilliance far beyond the capacity of their later descendants. In their fusion, they transformed simple hydrogen into helium, and in their death, scattered heavier elements into the void. With their ignition, the universe began to shine, and the cosmic dark ages gave way to the first era of light. These primordial stars, sometimes called population 3 stars, were unlike anything that exists today. They contained no metals, the astronomical term for elements heavier than hydrogen and helium, and as a result, they burned hotter, faster, and brighter. Their lifespans were fleeting on a cosmic scale, lasting only a few million years, yet their influence was profound. Through their nuclear furnaces, they created the first carbon, oxygen, nitrogen, and other elements that would one day form planets, life, and consciousness. In essence, these stars were the alchemists of the universe, turning nothing into the building blocks of everything. The light of these first stars pierced the surrounding darkness, initiating the epoch of reionization. Photons escaped the gravitationally trapped gas, ionizing hydrogen across vast regions of space. For the first time, radiation could travel unimpeded across the cosmos, illuminating the invisible filaments that had formed during the Dark Ages. It was a time of awakening, a period in which the universe not only formed its first structures, but also began to reveal them. The contrast between light and darkness became a defining feature, a cosmic metaphor for emergence from silence into awareness. This emergence of light also reshaped the behavior of matter on large scales. Gas that had been uniform now fragmented into dense clouds, forming clusters that would eventually become galaxies. Gravity guided the accretion of stars into these clusters, and the first galactic structures began to take shape. The universe was no longer a uniform expanse, but a textured tapestry, rich with nodes of matter and energy. Each new star contributed to the growing complexity, seeding the cosmos with elements and radiation, and guiding the formation of subsequent generations of stars. In this way, the cosmos learned to build, to organize, to structure itself. The death of these first stars was as important as their life. Many ended in spectacular supernova explosions, dispersing their enriched material across vast distances. These cataclysmic events were both destructive and generative, breaking apart old matter while seeding new potential. Within the shock waves of these explosions, clouds of gas were compressed, triggering the birth of new stars. In this cycle of creation and destruction, the universe developed a rhythm, a pulse that would define cosmic evolution for billions of years to come. Even now, every star we see, every atom in our bodies, carries the memory of these earliest stellar deaths. Philosophically, the first stars are a meditation on emergence from simplicity. From a nearly uniform sea of hydrogen and helium, brilliant, complex, and transient structures arose. They were luminous islands in a dark ocean, signaling that even in the void, energy could organize itself into patterns of extraordinary complexity. These stars were the universe's first storytellers, narrating the transition from chaos to order, from potential to form. In their light, the cosmos glimpsed its own possibilities, revealing pathways for evolution that would continue for eons. The first stars also highlight the interplay of contrast, of darkness and illumination, of simplicity and complexity, of brevity and permanence. They burned with intensity precisely because they were rare, fleeting, and extreme. Their brilliance was defined by the darkness around them, their transience magnified by the vast stretches of time in which nothing else existed. In contemplating these stars, we are reminded that existence often gains meaning through contrast, that moments of brilliance are amplified by the silence and stillness that precede them. In this epoch, the seeds of life's building blocks were being forged. The nuclear fusion within these stars produced not only helium, but also carbon, oxygen, nitrogen, and trace elements essential for chemistry. These elements would be scattered into the interstellar medium, mixing with gas and dust, creating the conditions necessary for the formation of planets, oceans, and eventually, living organisms. The first stars were, in a very real sense, the midwives of life, preparing the cosmos for the emergence of consciousness and reflection billions of years later. The era of the first stars is a meditation on impermanence and legacy. Though individual stars burned out in mere millions of years, their influence persists. Their light traveled across vast distances, shaping the ionization of the universe. Their material seeded the next generations of stars, and their deaths triggered waves of formation that would echo through cosmic history. Each star was fleeting, yet the structures they help form endure, reminding us that the transient can leave a permanent mark, that even the briefest existence can shape the trajectory of everything that follows. Finally, the ignition of the first stars is a poetic reflection on the universe learning to shine. After eons of darkness and stillness, energy and matter coalesced into luminous bodies, revealing the architecture of the cosmos and setting the stage for galaxies, planets, and life. The contrast between light and shadow, birth and death, simplicity and complexity became the rhythm of cosmic evolution. In observing the first stars, we witnessed the universe discovering its own capacity for beauty, for structure, and for memory, a silent revelation of the pathways from potential to existence, from darkness to illumination. With the first stars illuminating the void, the universe began to take on a form that would persist for billions of years. These early stars did not exist in isolation. They gathered into groups, bound by gravity, forming the first proto-galaxies. These were modest structures compared to the sprawling galaxies we see today, but they were the universe's first experiments in organization, the first conscious attempts of matter to shape itself into enduring forms. In the collisions, mergers, and interactions of these proto-galaxies, we can trace the origins of cosmic architecture, a blueprint for everything that would follow. The assembly of galaxies was neither quick nor simple. Gravity pulled gas and stars toward denser regions, while radiation and stellar winds pushed matter outward. The balance between attraction and pressure created complex, dynamic systems in which stars were born, lived, and died. Within these early galaxies, elements forged in the cores of stars spread through space, enriching the medium for subsequent generations of stars and planets. The universe, through these interactions, learned to recycle itself, to evolve toward greater complexity. What seemed like chaos from afar was actually a careful dance, the choreography of energy and matter in motion. At the heart of these proto-galaxies, massive stars burned fast and died young, creating black holes that quietly but profoundly influenced their surroundings. These early black holes became seeds for the supermassive black holes we find at the centers of galaxies today. Though invisible to the naked eye, they exerted tremendous gravitational influence, guiding the motions of stars and gas around them. They were silent architects, shaping galaxies through their invisible presence, reminding us that not all forces need to be visible to leave a mark. In this way, the universe began to understand structure, how forces, both apparent and hidden, interact to form enduring patterns. The growth of galaxies was accompanied by turbulence and violence. Collisions between proto-galaxies were common, and these interactions triggered waves of star formation, compressing gas clouds and igniting new generations of stars. Each collision was both destructive and creative, breaking apart old structures while giving birth to new ones. The universe's earliest architects were learning a fundamental principle. Creation and destruction are inseparable, two sides of the same cosmic rhythm. From this interplay emerged patterns that would endure through billions of years, giving rise to the spirals, ellipses, and irregular shapes we now classify as galaxies. As galaxies matured, they began to form clusters, networks, and filaments, creating a vast cosmic web. Matter was no longer evenly distributed. It gathered into intricate structures connected across immense distances. This web is the skeleton of a universe, the scaffolding upon which stars, planets, and life would eventually form. The contrast between void and structure, emptiness and density, is a recurring motif in cosmic evolution. It is through such contrast that the universe learns to define itself, distinguishing regions of activity from silence, energy from stillness. Within these galaxies, star formation became cyclical. Gas clouds collapsed under gravity, forming stars. Those stars burned and enriched the surrounding medium, then exploded in supernovae, dispersing elements into space. This cycle of birth and death created diversity, variations in star types, planetary systems, and chemical composition. It is a pattern that mirrors life itself: growth, decay, renewal. The universe, in nurturing these cycles, was creating not just matter, but a system capable of adaptation, evolution, and complexity. The emergence of galaxies also set the stage for the eventual formation of planetary systems. As clouds of gas and dust coalesced around new stars, disks formed, spinning and cooling over millions of years. Within these protoplanetary disks, matter clumped into planetesimals, then planets, moons, and other bodies. The universe was learning to build nested systems, stars giving rise to planets, galaxies giving rise to clusters, filaments giving rise to cosmic networks. Each level of structure reflected lessons learned at earlier stages, a fractal of order emerging from the interplay of energy, gravity, and time. Philosophically, the growth of galaxies is a meditation on emergence from simplicity to complexity. The universe, which began as formless potential, now displays patterns that are both beautiful and functional. From tiny quantum fluctuations to vast galactic structures, every stage of cosmic evolution demonstrates the principle that complexity arises from the accumulation and interaction of simpler components. The early galaxies are reminders that order does not need to be imposed externally. It can emerge naturally through the interplay of forces, laws, and chance. The light from these early galaxies traveled across space for billions of years, carrying the memory of their formation. When we observe distant galaxies today, we are looking back in time, seeing them as they were when the universe was still young. In this sense, galaxies are time capsules, preserving the history of cosmic evolution. They are the universe's storytellers, narrating the journey from formless potential to organized, luminous structure. In contemplating the first galaxies, we are invited to witness not just the birth of cosmic architecture, but the unfolding of a grand narrative in which forces, matter, and energy collaborate to create enduring form. Every star, every spiral arm, every cluster is an echo of the universe's earliest attempts to shape itself. The cosmos, once a trembling field of possibility, has now learned to write its own story in the language of gravity, light, and motion. And so, the early galaxies stand as monuments to cosmic patience, to the persistent rhythm of creation, and to the delicate balance between chaos and order. They remind us that from simplicity can emerge grandeur, that even in the absence of life, the universe is capable of artistry. These first luminous structures were the beginning of everything we now perceive as the cosmos, the first chapters in an unfolding epic that continues to this day. A story written in light, matter, and time. As the first galaxies formed and coalesced into clusters, the universe began to experience a new phase of organization and complexity. Gravity, the silent sculptor, continued to pull matter into ever larger structures, while radiation, pressure, and cosmic expansion shaped the delicate balance of formation. Within this expanding cosmic web, regions of gas cooled and collapsed, forming denser clouds that would give rise to successive generations of stars. This period marked the universe's first sustained experimentation with persistence and structure, as matter learned to assemble into increasingly intricate forms, and the seeds of long-term evolution were sown. The second and third generations of stars, building upon the remnants of the first, were richer in heavy elements or metals, created in the cores of their predecessors. These stars had more complex life cycles, longer lives, and varied fates, producing supernovae that distributed carbon, oxygen, silicon, iron, and other essential elements throughout their host galaxies. In this way, the universe was learning to enrich itself, to increase its chemical diversity and complexity. Every death of a star was a lesson in transformation, every explosion a means of dispersing possibility into new corners of space. The cosmos, through these processes, was not only forming structure, but also preparing the ingredients for planets, chemistry, and eventually life itself. Within these evolving galaxies, black holes continued their silent but profound influence. Some grew into supermassive black holes, anchoring the centers of galaxies and guiding the motion of stars and gas around them. Others merged and released gravitational waves, sending subtle ripples through the fabric of space-time. Though unseen, their presence shaped the flow of matter, the growth of galactic disks, and the evolution of star formation. These invisible forces remind us that much of the universe's order arises from hidden dynamics, from influences that are not immediately perceptible, but whose effects resonate across vast scales of space and time. The cycle of star birth and death in these galaxies established a rhythm that echoes through the cosmos even today. Clouds of gas collapse to form stars. Those stars forge elements and disperse them upon death, and the enriched material coalesces into new stars and planetary systems. Over billions of years, this cycle built galaxies of astonishing diversity and complexity, spirals, ellipticals, and irregular forms, each with its own history, character, and destiny. The universe, through these cycles, learned persistence, continuity, and the long-term effects of iterative processes. This period of galactic evolution also laid the foundation for the conditions necessary for planetary systems to emerge. As heavy elements spread through interstellar space, clouds of dust and gas began to coagulate more efficiently, forming protoplanetary disks around young stars. Within these disks, particles collided and stuck together, gradually forming planetesimals, moons, and eventually full-fledged planets. The universe was learning the art of nesting, how stars could give rise to planets, galaxies could give rise to stars, and cosmic structures could support nested hierarchies of organization. Each level of emergence reflected lessons learned at previous stages, a fractal of complexity unfolding across space and time. In this epoch, the universe's chemistry became increasingly diverse. Carbon, nitrogen, oxygen, silicon, iron, and other elements combined in countless ways, creating a fertile environment for chemical complexity. The conditions for organic chemistry and ultimately for life were being quietly prepared. While consciousness and biological systems were still eons away, the cosmos was already establishing the prerequisites for self-reflection and awareness. These early chemical processes highlight a subtle theme. Creation is cumulative. Each generation builds upon the last, and complexity emerges gradually from the iterative interplay of energy, matter, and time. Galaxies also interacted with one another more frequently during this era. Collisions, tidal interactions, and mergers became commonplace, triggering bursts of star formation and reshaping galactic structures. These interactions were neither entirely orderly nor completely chaotic. They were the universe experimenting with balance. Every collision redistributed matter and energy, creating new possibilities for structure and organization. The cosmos, through these grand interactions, was learning adaptability, resilience, and the unexpected creativity that arises from both destruction and synthesis. Philosophically, this epoch is a meditation on time, growth, and legacy. Individual stars are transient, individual galaxies are dynamic, yet the cumulative processes of the universe build enduring patterns. The cosmos demonstrates that longevity and persistence do not require stasis. Rather, they emerge from cycles, interactions, and the continuous interplay of forces. The universe is a teacher of iterative creativity, showing that even fleeting entities can leave permanent imprints on the broader structure of existence. The era of galactic evolution also brings to light the interconnectedness of cosmic systems. Stars form from gas clouds influenced by nearby stellar deaths. Galaxies grow through mergers and interactions, and chemical elements travel vast distances to participate in future generations of stars and planets. In this web of interdependence, the universe teaches a profound lesson. Nothing exists in isolation. Every process, every particle, every burst of radiation contributes to the unfolding narrative, shaping outcomes far beyond its immediate vicinity. Finally, the universe, through this epoch, was preparing for one of its most significant transformations, the formation of habitable worlds. The distribution of heavy elements, the shaping of planetary disks, and the establishment of stable stellar environments were all prerequisites for planets capable of sustaining chemistry complex enough to eventually produce life. This period is a reminder that preparation often precedes manifestation, that the universe takes its time to gather resources, refine processes, and establish conditions conducive to emergence. It is a cosmic lesson in patience and foresight, embedded in the very mechanisms of formation. In contemplating this era of galactic and chemical maturation, we see the universe as an active learner, a slow and deliberate creator. It experiments, it repeats, it adapts. Through cycles of creation and destruction, it builds complexity, richness, and the conditions for consciousness. The universe, in refining its galaxies and elements, is not merely assembling matter. It is orchestrating the potential for reflection, understanding, and awe. This is the quiet majesty of the cosmos, the patient unfolding of patterns that will one day give rise to worlds capable of asking the very questions we now ask about their origin. Within the ever-growing web of galaxies, the universe reached a point where the conditions for planetary systems became increasingly favorable. The dispersal of heavy elements from successive generations of stars enriched interstellar clouds, creating the building blocks not just for planets, but for the chemical complexity necessary for life. Carbon, oxygen, nitrogen, and other essential elements mixed in clouds of dust and gas, coalescing under gravity into protoplanetary disks around young stars. Within these disks, countless particles collided, fused, and gradually formed planetesimals, moons, and eventually planets. This process, repeated across billions of years and countless stars, set the stage for worlds capable of harboring complexity, diversity, and one day, life. As stars matured and planetary systems emerged, the universe demonstrated an extraordinary patience. The formation of stable planetary orbits required not only the precise distribution of mass, but also time, millions to billions of years of gravitational negotiation. Young planets faced violent collisions, asteroid bombardments, and instability before settling into enduring patterns. Yet, through this turbulence, the universe learned balance. It learned to combine chaos and order, violence and stability, in ways that allowed complex systems to persist. This delicate equilibrium would be essential not just for planets, but for life itself, which requires both consistency and variability to emerge and evolve. The diversity of planetary systems reflects the universe's subtle experimentation. Some planets are gas giants, massive and inhospitable, while others are rocky, temperate, and capable of supporting oceans. Some orbit their stars in perfect harmony, while others follow elongated, eccentric paths. Each system is a result of countless variables: the mass of the parent star, the composition of the protoplanetary disk, gravitational interactions with neighboring bodies, and random events like collisions. In this diversity, the cosmos teaches us that complexity arises from variation, that life and structure are the products of both law and chance, precision and unpredictability intertwined. The chemical richness of these early planetary systems is profound. Carbon-based molecules form the foundation of organic chemistry, while oxygen, nitrogen, phosphorus, and other elements provide the scaffolding for biochemical processes. Even the simplest molecules, water, methane, ammonia, are products of cosmic evolution, forged in stars, scattered across space, and incorporated into nascent planets. In this sense, the universe is a master chemist, preparing the necessary ingredients for life long before life itself appears. It is an illustration of patience and foresight on a cosmic scale. The universe sets the stage and gathers the components before the emergence of sentient awareness. Stellar activity also played a crucial role in shaping the potential for habitable worlds. Radiation from young stars can both nurture and threaten planetary atmospheres, driving chemical reactions that form complex molecules, yet also stripping away volatile compounds if conditions are too extreme. Supernovae, while destructive, seed neighboring regions with essential elements and trigger waves of star formation. In this delicate interplay of creation and destruction, the universe learned to calibrate environments suitable for sustaining long-term chemical processes, subtly guiding the emergence of complexity across space and time. The evolution of planetary systems is also a story of timing and scale. The universe operates on rhythms far beyond human perception, and the formation of planets spans millions of years. Dust grains collide slowly, gradually forming rocks, then larger bodies, in a process that mirrors the cumulative growth seen throughout cosmic history. These incremental steps highlight a universal principle. Small, persistent processes accumulate into large-scale structures. The universe teaches us that nothing of consequence emerges instantaneously. Even the planets, seemingly stable and solid, are the product of patient, iterative creation. Beyond the physical formation of planets, these systems create conditions for thermal and chemical equilibrium. Stable orbits allow temperatures conducive to the existence of liquid water, while diverse planetary compositions support a range of geological and atmospheric processes. Volcanoes recycle elements, magnetic fields shield atmospheres, and tidal interactions regulate climates. The universe, through countless iterations of planetary formation, learned to generate environments where complexity can persist over immense timescales. These lessons would ultimately become prerequisites for life, illustrating that the cosmos is not only a machine of energy and matter, but also a teacher, preparing conditions for the emergence of sentience and reflection. The poetic resonance of this epoch lies in its preparation for emergence. Planets are not merely celestial bodies, they are laboratories, incubators of chemistry and potential. Within their atmospheres and surfaces, molecules interact in intricate patterns, sometimes combining into structures that will eventually catalyze life. The universe, through these processes, demonstrates patience, foresight, and persistence on a scale that is almost unimaginable. It unfolds slowly, quietly, without urgency, setting the stage for phenomena that may not appear for billions of years, yet are encoded in the interactions of atoms and gravity from the very beginning. This period also highlights the interplay of randomness and determinism in cosmic evolution. While physical laws guide the motion of planets and the formation of chemical compounds, chance events, collisions, fluctuations in disk density, radiation bursts, shape the specific outcomes in each system. This combination of law and randomness creates diversity, allowing the universe to explore a wide range of possibilities. In this sense, planetary systems are experiments, each a unique variation on the themes established by stellar and galactic evolution. Through these experiments, the universe refines its processes. As planetary systems matured, the stage was set for the universe to experiment with one of its most profound possibilities: the emergence of life. Within the stable orbits of rocky planets, with temperatures and chemical compositions finely balanced, molecules began to interact in increasingly complex ways. Water, a molecule both simple and extraordinary, provided the medium for these interactions. It allowed organic compounds to dissolve, collide, and recombine, forming chains and networks capable of replication. In these subtle, hidden processes, the universe was learning to generate self-organization, to transform inert matter into systems capable of growth, adaptation, and memory. The earliest chemistry of life is both delicate and robust. On one hand, molecular interactions require precise conditions: energy flows, temperature ranges, and the presence of key elements such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. On the other hand, the same chemistry demonstrates resilience, with numerous pathways allowing molecules to combine, break apart, and recombine, gradually increasing in complexity. The universe, through countless cycles of formation and destruction, was perfecting the conditions for life, teaching matter how to organize itself into systems capable of perpetuating structure over time. Life's origins are inseparable from the flow of energy. Ultraviolet radiation, geothermal heat, and chemical gradients provide the energy necessary for molecules to form bonds and rearrange themselves into increasingly complex networks. This energy drives chemical reactions forward, breaking old connections and forming new ones, creating a dynamic environment in which complexity can emerge. The universe, in distributing energy through stars, radiation, and planetary heat, is simultaneously shaping the conditions for life, demonstrating that motion, flux, and transformation are essential to the emergence of self-organizing systems. From simple molecules, networks of reactions gradually gave rise to self-replicating systems, the earliest forms of life. These first proto-organisms were invisible to the eye, yet they carried within them the blueprint for evolution, the capacity to adapt, and the potential for diversification. Each replication event was a lesson in persistence, a small success in maintaining order against the entropy of the environment. Life, even in its earliest forms, illustrates a principle the universe has been refining since its first light, that patterns, repetition, and feedback can transform chaos into order. The oceans of these early worlds acted as cradles, buffering temperature fluctuations, concentrating chemicals, and providing a medium for molecular interaction. In this environment, molecules could encounter one another repeatedly, allowing increasingly complex reactions to occur. Minerals, clays, and rock surfaces provided scaffolds for molecules to attach, interact, and organize, catalyzing reactions that would otherwise be improbable. The universe, in sculpting planetary surfaces and providing chemical diversity, was orchestrating a laboratory of immense subtlety and complexity, one capable of producing the first sparks of life. Life, once it appeared, did not exist in isolation. It was part of an ongoing exchange between planetary environments, atmospheric chemistry, and the radiation of the parent star. Tides, volcanic activity, meteor impacts, and fluctuations in energy provided both challenges and opportunities, shaping evolutionary trajectories. The universe, in creating such dynamic and interactive environments, was teaching life resilience, adaptability, and the importance of feedback between system and environment. These lessons, though unconscious, are embedded in the very fabric of planetary and biological evolution. At the molecular level, evolution is iterative. Simple chains of RNA or proteins form, replicate, mutate, and adapt. Each success and failure contributes to the gradual emergence of more complex systems. This is a meditation on incremental creation, how persistence and repetition, guided by natural laws and chance, can produce complexity far beyond what is imaginable from the sum of its parts. The universe, in orchestrating these molecular dances over eons, demonstrates patience and the cumulative power of small events. Philosophically, the emergence of life is a bridge between the cosmic and the intimate. The same forces that shaped galaxies and stars now act within tiny planetary environments to organize molecules into living systems. Energy, gravity, chemistry, and time converge, transforming the inanimate into the animate. Life is not separate from the universe. It is an expression of the same principles that guide cosmic evolution on the largest scales. In this sense, each living organism is a continuation of processes that began in the first moments after the Big Bang, a microcosmic reflection of the universe's capacity to organize, remember, and persist. The early biosphere also introduces the concept of contingency and possibility. Evolution is not predetermined. It is guided by laws but shaped by randomness, chance encounters, and environmental shifts. The universe, by creating diverse planetary and chemical conditions, allows for a vast array of outcomes. Life is not a singular inevitability, but a possibility among many, contingent upon subtle balances and interactions. This teaches a lesson about the fragility and resilience inherent in complex systems, highlighting both the rarity and wonder of emergence. The first ecosystems, though microscopic, exhibited networks of interaction. Molecules influenced one another, chemical gradients shaped reactions, and nascent life forms competed and cooperated in subtle, invisible ways. Feedback loops, cycles, and interdependencies emerged, mirroring the larger patterns of galactic and stellar evolution. In these early networks, the universe demonstrates a principle that echoes across scales. Complexity emerges from interaction, from feedback, and from the persistent flow of energy and matter across time. Ultimately, the origin of life is a meditation on patience and subtlety. The universe does not force creation. It provides conditions, flows energy, and allows systems to self-organize. Through billions of years of preparation, the formation of stars, galaxies, planetary systems, and chemical environments, the cosmos orchestrates the emergence of life as a natural consequence of its processes. Life, in this sense, is not an anomaly, but a continuation of cosmic evolution, a reflection of the universe learning to know itself through molecular interaction and self-replication. In contemplating the emergence of life, we are invited to feel the continuity between the vastness of cosmic history and the intimacy of the first molecules stirring in primordial oceans. The universe, once formless and silent, has now produced complexity capable of reflection, adaptation, and growth. Each living system carries within it the echo of stars, galaxies, and cosmic evolution. Life is a quiet testament to the universe's capacity for persistence, creativity, and transformation, an intricate meditation on the processes that unfold when matter, energy, and time converge in delicate balance. With life now emerging on select planets, the universe entered a new stage of reflection and complexity. The first microorganisms were tiny, invisible architects of change, yet their presence began to alter planetary environments in profound ways. Through metabolic processes, early life influenced atmospheric composition, recycled nutrients, and contributed to chemical gradients that would, over immense spans of time, support increasingly complex organisms. In this subtle interaction between life and environment, the universe demonstrated a principle it had been refining since the first stars. Systems evolved not in isolation, but through dynamic interplay, feedback, and adaptation. The rise of photosynthetic microorganisms marked a turning point. By converting sunlight into chemical energy, they released oxygen as a byproduct, slowly transforming the composition of planetary atmospheres. This oxygenation created new opportunities for chemical reactions, setting the stage for the evolution of more complex life forms capable of harnessing this abundant energy. The universe, in this process, was learning the value of cooperation and the emergence of systemic effects. Small agents acting collectively can reshape entire environments, opening pathways for new possibilities that were previously inaccessible. As complexity increased, life began to diversify. Single-celled organisms evolved into multicellular forms, developing specialization and interdependence. Cells organized into tissues, tissues into organs, and eventually, organisms capable of movement, sensation, and reproduction emerged. Evolution acted as a sculptor, guided by selective pressures, random mutation, and environmental opportunity. The universe, through this iterative process, was demonstrating how persistence, variation, and feedback create structures of increasing sophistication, and how long-term systems can emerge from countless small adjustments. Planetary ecosystems became intricate networks of energy flow and chemical recycling. Producers, consumers, and decomposers formed interdependent cycles, balancing inputs and outputs, and stabilizing environmental conditions. The emergence of these networks reflects a universal principle. Sustainability arises from interaction and interdependence. The universe, by providing energy gradients, chemical diversity, and temporal stability, was orchestrating conditions under which complex adaptive systems could flourish, demonstrating a continuity of learning from cosmic structures to biological ones. The development of nervous systems and sensory organs marked the next frontier. Organisms evolved the capacity to detect, process, and respond to information from their surroundings. This ability to perceive and react represents the universe's first steps towards self-awareness within life itself. Through neurons and networks, information could be stored, transmitted, and used to influence behavior, creating the basis for memory, learning, and adaptation. In this, the cosmos was not only shaping matter, but beginning to cultivate reflection, a microcosmic echo of the processes that had sculpted galaxies and stars. With perception came behavior. Organisms began to move purposefully, seeking resources, avoiding danger, and interacting with each other. Social structures emerged in some species, cooperation and competition intertwined to drive evolutionary progress. The universe, in guiding these interactions, was learning the principles of agency, feedback, and adaptation on a scale far smaller than galaxies, yet no less significant. These early behaviors foreshadowed the eventual emergence of intelligence and conscious awareness, suggesting that the universe itself, through life, was exploring the pathways of reflection. Over millions of years, ecosystems expanded in complexity. Food webs developed, predation and symbiosis shaped evolutionary strategies, and environmental pressures drove diversification. Life's evolution was not linear, but a branching, iterative process, mirroring cosmic evolution on planetary scales. The universe, through this intricate dance, was demonstrating how nested systems operate, how structures within structures evolve, and how complexity accumulates through feedback loops and repeated interaction over time. The rise of multicellular organisms introduced new forms of organization and problem-solving. Developmental processes allowed differentiation of cell types, the formation of specialized organs, and the emergence of coordinated behavior. Evolutionary pressures favored adaptability, resilience, and the capacity to exploit diverse ecological niches. The universe, through these processes, was refining the mechanisms by which complex systems can maintain themselves, adapt, and innovate, revealing a continuity between cosmic evolution and the emergence of life on smaller scales. Environmental feedback became increasingly crucial. Life began to alter planetary conditions in ways that further influenced evolution, creating a dynamic interplay between organism and environment. Oxygenation of the atmosphere, soil formation, and climate regulation are examples of how life co-evolves with planetary systems. This demonstrates a fundamental principle. Complexity is emergent, not imposed. It arises through iterative interaction, feedback, and adaptation, whether in the folding of galaxies, the circulation of planetary systems, or the development of ecosystems. The progression of life on planetary scales mirrors cosmic development. Just as gravity organizes stars into galaxies and filaments, and nuclear processes enrich matter with chemical diversity, biological processes organize matter into networks of increasing sophistication. Both systems rely on feedback, variation, and energy flows to generate enduring complexity. The universe, through the evolution of life, has created a nested reflection of its own principles. Structure emerging from interaction, memory encoded in patterns, and adaptation guiding the formation of increasingly intricate systems. Finally, this epoch demonstrates the bridge between the cosmos and consciousness. From the first stars to multicellular life, the universe has been cultivating systems capable of complexity, awareness, and reflection. Life represents an extension of cosmic processes into the intimate scale of organisms and ecosystems. By observing the emergence of complex life, we witness the universe's ongoing capacity for self-expression, a continuation of patterns initiated in the earliest tremors of spacetime, through galaxies and stars, now echoed in the intricate dance of living systems on distant worlds. As multicellular life diversified and ecosystems became increasingly complex, the stage was set for the emergence of intelligence, a subtle, profound step in the universe's unfolding narrative. Intelligence is not merely a property of living organisms. It is a process through which the universe begins to reflect upon itself. Nervous systems evolved, sensory inputs became more sophisticated, and behaviors grew increasingly adaptive. Some species developed problem-solving abilities, memory, and learning, allowing them to navigate challenges and opportunities in ways that were anticipatory rather than purely reactive. In this gradual emergence, we see the universe extending its own principles of complexity, feedback, and adaptation into sentient forms capable of awareness and reflection. The evolution of cognition brought a new layer of interaction between organisms and their environments. Intelligence allowed living beings to manipulate their surroundings, to alter ecological relationships, and to create structures and tools that extended their influence. Early cognitive life forms discovered patterns, anticipated consequences, and began to communicate. Each of these capacities represents an amplification of processes that had been occurring since the first stars formed. The organization of matter, the feedback between systems, and the accumulation of information across time. Through intelligence, the universe was learning to encode memory not only in matter, but in behavior, strategy, and social organization. Social behavior became increasingly sophisticated alongside cognitive development. Organisms began cooperating, competing, and forming networks of interdependence. Communication, whether chemical, visual, or auditory, allowed the transfer of information between individuals, amplifying adaptive strategies and enabling collective learning. In these early social networks, we witnessed the principles of emergence applied at yet another scale. Patterns of interaction producing stability, innovation, and resilience, echoing the same dynamics that shaped galaxies, star clusters, and ecosystems. The universe's lessons in structure, persistence, and adaptability are repeated at every level, from cosmic webs to neural networks. The development of tools, symbols, and eventually language represents a further amplification of intelligence. By externalizing thought, early intelligent beings could manipulate not just the physical environment, but the informational environment as well. Memory extended beyond individual lifespans, stored in artifacts, traditions, and systems of knowledge. The universe, which had begun with matter and energy, had now produced agents capable of abstraction, foresight, and intentional creation. Intelligence becomes a mirror through which the cosmos observes itself, reflecting its history, processes, and potentials back upon itself. Environmental interaction played a crucial role in shaping intelligence. Challenges, scarcity, predation, and opportunity drove the evolution of problem-solving skills, adaptability, and innovation. In parallel, intelligence enabled organisms to alter their environments, creating feedback loops in which cause and effect intertwined across both natural and behavioral dimensions. This coevolution illustrates a profound principle. The universe fosters systems capable of both learning from and influencing their surroundings, creating nested cycles of adaptation that mirror the broader processes of cosmic evolution. The emergence of intelligence also introduces temporality and foresight in a new dimension. Whereas chemical reactions, evolutionary pressures, and cosmic processes operate over vast timescales, cognitive life adds planning, memory, and anticipation to the mix. Beings capable of reflection can consider the past, predict the future, and make decisions based on complex scenarios. In doing so, the universe effectively extends its temporal awareness, embedding information, intention, and strategy within living systems that act as agents of its own reflection. Cultural development emerged as an extension of intelligence, allowing information to accumulate and be transmitted across generations. Knowledge, innovation, art, and storytelling became means of encoding collective memory and shaping future action. These processes echo the cumulative complexity seen in galactic evolution, planetary formation, and biological adaptation. Just as stars build elements over generations and galaxies organize themselves through gravity and interaction, intelligent life accumulates knowledge, creating increasingly sophisticated structures of meaning and understanding. Intelligence, in this cosmic context, is both emergent and reflective. It is emergent because it arises naturally from the interplay of matter, energy, and environmental constraints over vast timescales. It is reflective because it allows the universe to become aware of its own patterns, structures, and history. Through cognition, the cosmos begins to contemplate itself, extending the principles that govern stellar, galactic, and biological evolution into conscious observation and analysis. Philosophically, the rise of intelligence is a meditation on potential realized. The universe, once formless and silent, has now produced beings capable of asking questions about their origins, their environment, and the nature of existence itself. This capacity for inquiry is not an accident. It is the culmination of processes refined over billions of years: star formation, chemical enrichment, planetary evolution, and biological complexity. Intelligence is the universe's capacity to reflect, to measure, and to comprehend, a mirror of the same principles that have guided its evolution from the first moments of expansion to the present. Ultimately, The emergence of intelligence transforms the universe from a collection of interacting matter and energy into a network capable of reflection, interpretation, and anticipation. Consciousness becomes a continuation of cosmic evolution, a process in which the universe itself begins to understand and articulate its history and possibilities. Through intelligent life, the cosmos acquires the ability to encode, transmit, and reflect upon information, turning observation and inquiry into a new form of structure, and extending the rhythm of emergence and adaptation into a domain of self-awareness. In contemplating the rise of intelligence, we are invited to recognize the continuity between cosmic history and conscious reflection. From the first fluctuations in matter to the formation of stars, galaxies, planets, and life, each stage has prepared the conditions for awareness. Intelligence is a meditation of the cosmos upon itself, a continuation of the rhythms of creation, organization, and adaptation that began with the very first stirrings of the universe. It is the universe's way of learning to know, and in that knowing, it finds both reflection and wonder. As intelligence matured, the universe reached a stage where it could witness, through conscious life, the vast and intricate narrative it had been unfolding for billions of years. This is not merely the observation of stars or galaxies, but the contemplation of existence itself, of energy and matter, of time and space, of beginnings without form and the structures that eventually emerged. Consciousness allows the universe to reflect on its own history, to perceive the delicate balance between chaos and order, and to marvel at the astonishing interplay of forces that led from formlessness to complexity. In this quiet reflection, the cosmos finds a voice, not through sound or light, but through thought, perception, and understanding. The journey from the first cosmic fluctuations to intelligent life reveals a recurring pattern: emergence through iteration. Simple elements coalesced into stars. Stars enriched galaxies with heavier elements. Galaxies organized into cosmic webs. Planets formed in the nurturing arms of stars. Life emerged from chemical complexity. And life, in turn, evolved cognition and awareness. Each stage depended on the previous, yet each also introduced novelty, unexpected, delicate, and transformative. The universe demonstrates that creation is not a single event, but a continuum, a meditation in time, unfolding with patience, subtlety, and extraordinary precision. Through consciousness, the universe also gains perspective. Intelligent beings, aware of their place in space and time, can trace the history of matter and energy from the earliest epochs of formation to the present. They can perceive the birth and death of stars, the assembly of galaxies, and the emergence of life on fragile worlds. In doing so, they become active participants in the cosmic story, translating observation into understanding and understanding into wonder. Awareness, in this sense, is a bridge. It connects the immeasurable scales of the cosmos with the intimate scales of perception, bridging the gap between the universal and the individual. The interplay of temporality and reflection becomes especially profound. Consciousness allows the universe to not only remember, but to anticipate, to hypothesize, to imagine what might be. Through thought, calculation, and speculation, intelligent beings can reconstruct past events and project potential futures, creating a dynamic narrative that mirrors the processes of cosmic evolution itself. In contemplating stars and galaxies, life simultaneously interprets and continues a story, demonstrating the universe's capacity for self-awareness and the emergence of meaning from matter and energy. Philosophically, the presence of intelligence elevates the universe from a stage of physical processes to one of reflection and meditation. The cosmos, through the lens of conscious life, gains the ability to appreciate its own intricacy, to observe the delicate dance of forces and forms, and to sense the interconnection of all things. This reflection does not alter the laws of physics, yet it imbues existence with a sense of narrative, a recognition that the unfolding of time and space is not arbitrary, but part of a continuous, elegant progression from formlessness to order, from simplicity to profound complexity. As conscious life continues to expand, explore, and understand, It also extends the reach of the universe's self-awareness. Observation becomes creation, curiosity becomes exploration, and reflection becomes insight. Every discovery, from the composition of distant stars to the dynamics of molecular life, deepens the universe's understanding of itself. In this sense, intelligence is the continuation of the cosmic process, a subtle but extraordinary means by which the universe can know, remember, and reflect upon its own existence. In the end, the journey from a universe before it had formed to a cosmos capable of conscious reflection is a meditation on emergence, patience, and interconnection. From the first quantum fluctuations to the ignition of stars, the assembly of galaxies, the formation of planets, and the rise of life and intelligence, each stage builds upon the last, forming a continuum of creation that is both ordered and unpredictable, silent and luminous, transient and enduring. The universe teaches us that complexity, awareness, and beauty emerge not instantaneously, but through iterative processes across time and space. This final stage, in which the cosmos contemplates itself through intelligent beings, is not an endpoint, but a culmination of the principles it has nurtured since the beginning: energy, matter, feedback, and reflection. Consciousness allows the universe to recognize its history, to perceive the extraordinary patterns that have emerged from formlessness, and to feel wonder at the interplay of forces that produce stars, galaxies, planets, and life. In this quiet, contemplative awareness, the universe completes a cycle, from the unformed void to a cosmos capable of self-recognition, capable of reflecting upon the grand meditation of existence itself. And so, the story of the universe, from its earliest moments before form, through the ignition of light, the shaping of galaxies, the birth of planets, and the emergence of life and intelligence, finds its expression in reflection. The universe, once silent and formless, now observes, remembers, and marvels. In conscious beings, it discovers a voice, a mirror through which the vastness of time and space can be comprehended and appreciated. The cosmos, in its patient unfolding, has created not only matter and structure, but the capacity for awareness, completing a journey from potential to reflection, from silence to understanding, from formlessness to wonder.